Hi everyone, this is Whit from Brainstem Tutoring, and in this video we want to talk about resonance structures, how I approach them, how I figure out if there are resonance structures, and drawing them. A great example would be carbon dioxide. Of course, we're just going to approach it like any other Lewis dot structure. Number one, count the number of valence electrons, and I believe that's 16 valence electrons. 2, skeleton structure, carbon in the middle, oxygens on the side, and we just used up 4 of our electrons. Octet rule step number 3, we're going to make these oxygens happy. I always like to start with the outside atoms. And there's a problem. We just ran out of electrons, and the octet rules are not satisfied. Step number 4, the Goldilocks logic. This is the case of not enough electrons. Not enough electrons, so we need to add bonds. We talked about that in a previous video. But here is the kicker. In the last video, I tried to pick a molecule that only had one place you could put the bonds. When you're adding bonds, you need to ask yourself, is there one correct way to add more bonds, or is there more than one correct way? So, I'm going to come through this, and we are missing 2 pairs of electrons, so we need to add 2 bonds. The most obvious thing at first, and this is what most people think, and it's the best structure, is we take a bond or a lone pair from each of the oxygens and sort of share the load. Now, all the octet rules are obeyed, and it has 16 valence electrons. That's a valid Lewis dot structure. Now, there is no rule that says it has to be symmetric. That's not a rule, right? So you can make an oxygen from the left share 1 and an oxygen from the right share 1. But who says you can't make the oxygen on the left share both of them and satisfy the carbon? So structure number 2 is the oxygen on the left donating both of the necessary bonds. And if the oxygen on the left can do it, the oxygen on the right could have done it, giving us our third structure. Sorry, let me put those electrons in the right spot. Wonderful. All of these have full octets, happy octets, and 16 valence electrons, so they're all valid. This structure is the best, but it's not because it's symmetric. It has to deal with something with formal charge, and I am going to talk about formal charge in a future video. I hope this helps. If you're adding a bond, stop, pause, think to yourself, is there more than one place I could put this bond? If so, there's more than one valid structure, aka resonance structures. I hope this video helps. If you have any questions about this video or resonance structures in general, leave a comment, email us, and I hope this helps. Thank you.